You're listening to the N2K Space Network.
You know, it's tough out here for space nerds sometimes. Here we are, living in a new space era, new technologies and breakthroughs happening all the time, new records being broken, like the one that SpaceX just broke yesterday. And through it all, a lot of people are just kind of like, meh. But I mean, come on. Okay, if you think nerding out is a bit too embarrassing, don't worry. I've got you covered.
T-minus 20 seconds to LOS speed rest to go for deploy. Roger roll.
Today is September 20th, 2023. I'm Maria Varmazis, and this is T-minus. SpaceX sets a new record. Sierra Space completes a fifth subscale test of the life habitat. Astroscale has been awarded $25 million to advance space mobility and logistics capabilities by the U.S. Space Systems Command. And our guest today is Andy Atherton, COO at Solestial Solar, on the development of solar technology for spacecraft. So stay with us for that discussion. And now on to today's intelligence briefing. So let's not get too jaded about how incredible some of the news is, really, just because SpaceX makes it look easy. We know it isn't at all. The company has just broken its own record with one of its Falcon 9s, whose first stage has now been reused 17 times, with its latest mission taking a batch of 22 Starlink satellites to low Earth orbit last night from Cape Canaveral in Florida. I should note, 2 other Falcon 9 first stages have also been reused 16 times each. What a time we're living in where this fantastic feat doesn't seem to get more than a passing acknowledgement, huh? Well, we thought it was worth a tip of our T-minus cap, to say the very least. Sierra Space has completed a 5th subscale test of their life habitat. LIFE stands for Large Integrated Flexible Environment, which the company worked on with the soft goods technology partner ILC Dover. The Life Habitat module is a 3-story commercial habitation, science, and biopharma platform designed to allow humans to live and work comfortably in low Earth orbit, or LEO, and beyond. Sierra Space says this latest milestone, which is the first one in the testing campaign to include a metallic window substructure, or blanking plate, will now propel the company into full-scale testing of life by the end of this year. U.S. Space Systems Command's Assured Access to Space Directorate, in collaboration with the Space Development Corps' Space Enterprise Consortium, has awarded a $25.5 million contract to Astroscale US Inc. to advance space mobility and logistics capabilities. This program realizes the strategy of acquiring commercially available platforms and procuring services for national security missions, accelerates delivery of new capabilities, and reduces development costs. Additionally, it demonstrates the Space Force's continued leadership, agility, and commitment to innovations advancing space mobility and logistics for the warfighter. Astroscale will deliver a servicing vehicle prototype that will provide in-space refueling for compatible satellites by 2026. The U.S. Defense Advanced Research Agency, also known as DARPA, is looking for help to find new ways to project U.S. military power in space. The agency is seeking innovative concepts from small businesses and non-traditional defense contractors in the technical domain of space superiority. This is the second topic issued under the agency's Bridges Initiative, which stands for Bringing Classified Innovation to Defense and Government Systems. The agency is looking for new methods and technologies that may provide warfighters with disruptive options for protecting and defending space systems across the competition continuum. Companies are being encouraged to submit a 4-page or shorter proposal for review, with initial proposals being accepted by October 1st. The agency will continue to accept and evaluate proposals on a rolling basis until the final deadline of March 15th, 2024. And if you're interested, more details can be found in the link in our show notes. The Aerospace Industries Association, known as the AIA, sent a letter to the U.S. National Security Advisor urging the National Security Council to more specifically assess how designating space as a critical infrastructure would affect space systems and the space industry. The National Security Council is currently evaluating the United States' critical infrastructure under Presidential Policy Directive 21, Critical Infrastructure Security and Resilience, to determine if any changes should be made to the current list of 16 sectors classified as such. The letter requests that the National Security Council conduct a cost-benefit analysis to understand the impacts of such a designation on specific space capabilities. And to read the letter in detail, we've included a link to the whole thing in the selected reading section of our show notes for you. A joint study by the U.S. military, ComSpoc, the Center for Space Standards and Innovation, LSAS Tech, the Space Data Association, Intelsat, and SES, has been looking at tracking satellites. And the results show that government and commercial satellites that can maneuver more rapidly and more often are very difficult to accurately track. And the study warns that this can lead to erroneous assessments of spacecraft whereabouts and increase the risk of on-orbit crashes. The study also looked at vulnerabilities to Space Force and U.S. Space Command satellites caused by misplotting movements of adversary satellites. It identified 6 ways to help resolve the maneuvering problem for satellite trackers. Number 1, sharing of ephemerides, which is the position at any one time, maneuver plans, astrometric observations, and spacecraft characteristics by spacecraft operators. Number 2, incorporation of commercial space situational awareness, or SSA, and government observational data. Number 3, curation and fusion of such data by commercial SSA. Number 4, orbit determination algorithms that can recover quickly from maneuvers. Number 5, orbit propagation tools that can predict through planned maneuvers. And number 6, data sharing standards development and widespread adoption. Yep, we all know it's getting crowded up there, folks, so let's hope the industry adopts these resolutions for the best space traffic management. Remote sensing data technology company Skywatch has announced its partnership with UK-based thermal imagery company Satellite View. The Canadian company's press release says the addition of Satellite View's thermal imagery to Skywatch's Earth Cache platform enables customers to use high-resolution precision imagery for climate, environmental, industrial, and intelligence and defense applications. The companies say they are moving towards a positive net zero future, using high-resolution thermal data to understand a lot more about where changes are needed to stop heat loss and decrease emissions. Thales Alenia Space and Nigerian Communications Satellite Limited, known as NIGCOMSat, have renewed their partnership on the development of satellite-based augmentation system. Through this agreement, NIGCOMSat will provide access to the satellite-based augmentation system payload of NIGCOMSat 1R satellite to Thales Alenia Space to disseminate satellite-based augmentation system signals in Africa. And that little helicopter on another planet has set a new record. Ingenuity, the little Mars helicopter that could, has successfully completed its 59th flight, reaching its highest altitude yet at 20 meters above the red planet's surface. The rotorcraft was in the air for over 142 seconds. And as always, go Ginny! And we've included the stats on Ginny's flight log in our show notes, along with all the other stories we've mentioned in this episode. And of course, as always, we've added a few extra to the selected reading section for you. One of them's an opinion piece from The Hill on Space Force. One's from Forbes on a Colombian student's capsule holding asteroid dust. And the last one's from TechCrunch on Magnastar. They're all at space.n2k.com, and just click on this episode. Hey T- crew, if you find this podcast useful, please do us a favor and share a 5-star rating and short review in your favorite podcast app. It will help other space professionals like you to find the show and join the T- crew. Thank you so much for your support. We really appreciate it. Our guest today is Andy Atherton, COO at Solestial Solar. I started off by asking Andy to give us the pitch for Solestial.
So like I said, we're the solar energy company for space. What that means in the short term is solar panels for space applications, for spacecraft. And we have unique technology that allows us to do that much less expensively and at much higher scale than has been available with incumbent space-focused solar technology. It's a really challenging environment. There's temperature extremes, radiation, UV, atomic oxygen. There's all these complex and difficult environmental factors. So, these are not the panels that are on your roof. They need to be highly specialized. And in the past, that's meant very high cost and very low capacity for production. And by using silicon and improving that material for the space application, we're able to address both of those barriers. After launch cost, energy availability and cost of energy is the next bottleneck for human progress in space. And our goal is to solve that.
I was reading your panels self-cure from radiation damage. That's really fascinating. Could you tell me a little bit more about that, please?
Sure. Well, I am not the scientist. You've got the business guy here, but I'll try to do my best. So what we've figured out how to do is create low temperature annealing in silicon. So silicon degrades rapidly with exposure to radiation in space. That's the problem. That's why you can't just fly roof panels. That's why these exotic, expensive, capacity-limited technologies were developed in the first place. What we figured out a way to do is through two proprietary elements, we figured out a way to create low temperature annealing in silicon. So let me explain that. So what low temperature annealing is why efficiency goes down with exposure to radiation is the high energy particles create defects in the crystal structure of the silicon, which interferes with its ability to generate power. That's what's happening. Now, when you heat up the material, those defects go away. This behavior has been observed in standard terrestrial silicon at very high temperatures, like hundreds of degrees C. That's interesting, but it's not useful because you don't see those temperatures in the operating environment in space. So the innovation is our ability to do that at lower temperatures, at temperatures that you encounter normally in the operating environment. So that actually makes it useful. We accomplish that in two ways. One is our cells are very thin. So a typical terrestrial cell is 160 microns. Our cells are only 20 microns. That means they take less radiation damage in the first place. We also change the chemical composition of the commodity silicon wafer to promote the formation of defects that are easier to cure at lower temperatures. And these two elements work together to create essentially a radiation-proof cell. Just as long as that cell sees, for some period of its operating cycle, temperatures that are 80 degrees C or above, radiation damage is cured and you're back to starting efficiency. Interestingly, that enables us to rethink the packaging. So we're just talking about the cell at this point. If you have a radiation-proof cell, you can rethink the packaging. You don't need cover glass to shield from radiation, for example. If you don't need cover glass, you don't need a stiff substrate to keep that glass, which is brittle, from cracking. So we encase our cells in polymers, coat the polymers to protect from UV and atomic oxygen. And we end up with our production unit, our product is a blanket, a flexible, thin, low mass, high efficiency blanket.
Yeah, that word blanket definitely popped out when I saw it. I said, that's really fascinating. And I mean, I think I saw a video on your website where it almost is like rolled up like a poster tube, which was just so neat.
10 centimeter bed radius.
Yeah, that's super neat. Not something you see every day with solar. So that's fascinating to see. And I'm curious, what this must open up a lot of different pathways for application and design as well when we're talking about missions to space, does it not?
It does, although the flexibility is kind of it's a neat property, and it's very accessible to I'm not going to accuse you of being a layperson, but it's very accessible to a layperson. It's very noticeable. It's visible, right?
Yeah, I am a layperson. That's totally okay.
You and me both, really. But the flexibility is actually not the most valuable characteristic of the blanket. That's not what folks are most interested in. What our customers value the most is cost, low mass. So there's two pieces. It's flexible. It's also very thin. That allows it. It's a very low mass product. That matters too. So the ability to have high efficiency with low mass, low cost, and high manufacturing scalability, that's really the most important thing. Now, the flexibility does open up some interesting applications. So for space, there's two kind of that come to mind immediately. One is a rollout array structure. So rather than having a panel that sort of unfolds, which is the typical, if you've got a stiff substrate requirement, that's the typical configuration, that or body mounting. But what a flexible, rollable blanket allows is a rollout array that can save both mass and volume in its stowed configuration, and then just roll out with a boom instead of having these folded panels. So that's pretty interesting. Another interesting application is if you have not a flat surface. So let's say you're trying to put something on, a rounded surface. It's nice to have a flexible product that doesn't crack, or you don't need to create some weird structure to support it. So there's a couple interesting applications that come out of the flexibility.
100%. And your point's well taken. I mean, I just wanted to move on to the question I had about some of your partnerships that you're working on. So there was the partnership with Atomos. Huge. Could you tell me a bit more about what that is, what you're looking at, what you're building right now?
Sure. They're a company like us that's early in their development. We went through the same Techstars class back in 2019. That was before I joined, but we have a common history. And we're providing them with a main power solution for their first two missions. So we're super excited about working with them, and we're humbled by their confidence in us. They're a great company, and we've got a great solution for their application.
That is clearly something that's happening right now. And you must be looking also beyond that to the future. Anything that you all are thinking about or in the future, or any long-term goals that you want to share?
So we're working with a number of customers, and you will see more announcements in the coming months here of similar agreements with customers to provide main power for our missions. So we're very much in the commercialization phase of our technology. Atomos is the first of many. Longer term, though, so looking over the horizon, we really see a huge opportunity for energy in space writ large. So, solar panels for spacecraft is a nice, fixed target in the short term, but we have much broader ambitions moving towards utility scale energy infrastructure for applications in space.
And I'm going to ask the question I asked earlier because I know it's basic. So when am I getting a solar blanket for my roof?
We can get you a solar blanket for your roof.
It won't help me much, though, will it?
The issue is our technology is expensive. While it's much cheaper than traditional space solar, it's much more expensive than terrestrial solar because it has all these special, the ability to survive in this really harsh environment. So you don't need that on your roof unless your roof is in a much weirder place than I bet it is.
I was going to say I can't afford it. So that's totally legit. But do you see, in all seriousness, do you see any potential for terrestrial application for something like this, or is that just not?
We've actually had some conversations, and we're in active discussion with a couple folks about terrestrial applications. Obviously, the radiation resistance and those attributes don't matter, but the form factor. So having something that's thin and flexible is valuable and justifies the increased expense in certain applications. One company that comes to mind is thinking about how to embed our blankets in a solar roof for an electric vehicle, for example. So, thick cells wouldn't work, but thin cells will. And so in an environment like that, we're focused on space. We are the solar energy company for space.
We'll be right back. And welcome back. And we've all been there. Trying to return home from a long trip abroad, you get to the airport and you see the dreaded notice on the board, flight canceled. Now, how are you going to get home and how long is it going to take? Well, next time I'm catching a few Z's on an airport bench and feeling a bit miffed about my situation, I'll try to console myself that it could always, always, always be worse. Because try being in space when your flight gets canceled. And the next trip home is another 6 months away. That airport bench might not seem so bad. I'll put myself in NASA astronaut Frank Rubio's shoes because he's officially been in space for over a year. Had he known he'd been up there that long? In his words, if they had asked me up front before training, because you do train for a year or 2 years before your mission, I probably would have declined. It would have hurt, but I would have declined. And that's only because of family, things that were going on in the past year. Had I known that I would have had to miss those very important events, I would have just had to say thank you, but no thank you. Can you blame him? But of course, he has a mission to carry out, and carry it out he did. And Rubio is scheduled to come back home, back to Earth, a week from today. So relief is in sight here. So after seeing his family and getting in a lot of what I imagine are very overdue hugs, what Rubio says he's most looking forward to upon his late September return to Earth is, any guesses? Better food? Fresh air? A pumpkin spice latte? No. Rubio said, just going out in the yard and enjoying the trees and the silence. Up here, we kind of have the constant hum of machinery. So I'm looking forward to just being outside and enjoying the peace and quiet. That's it for T- for September 20th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of our podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K's strategic workforce intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karp. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.